Welcome everyone, I am Anya and I've been working with Matt and Sally, and we're going to present to you our work on developing a service planning decision support tool to tackle inequalities and minimise carbon output. And this has very much been a cross-sector collaborative project where we have developed a generalisable tool, but we've piloted it with one set of data, and we're going to talk you through what we've done now. So the background to this project was to bring together three important priority areas for the NHS at the moment. Firstly, the inequalities agenda, where the NHS Constitution and NHS long-term plan include a mandate for the NHS to reduce inequalities. Secondly, the NHS net zero agenda, where the NHS has an ambition to reach net zero by 2040. And thirdly, the digital and transformation agenda. And we wanted to bring all of these three together and make a decision support tool to help service planners consider these issues. So what did we aim to do? We aimed to simplify the process of calculating patient travel carbon emissions and identifying health inequalities at scale for any service. And what have we done? Well, we've managed to produce a tool which is usable for any service, and we've piloted it with sexual health data from a service within Derbyshire. An overview of our methods. First of all, we imported the data and we've cleaned and processed it. We then run a machine learning model which identifies features and characteristics associated with patients who do not attend their appointments. Secondly, it runs an automated health equity audit which summarises unmet need for the service compared to the general population. And thirdly, it estimates the carbon emissions associated with patient travel to the service and then produces an automated report of all significant findings.
So the first thing that happens is we run the machine learning model for the unattended appointments. This analyzes the processed service data with 9 logistic regression machine learning variants. It then identifies the optimum one of those 9, and then it returns the 5 most influential features associated with patients not attending their appointments using this optimum model. It then undertakes an automated health equity audit for n number of conditions, as is meaningful for the given service data in use. For our project, this is based on contraception and gum, but it could be anything as relevant to the use case. The slide shows some example outputs, specifically using the dummy data that we generated from the automated health equity audit. On the left is a chart comparing the proportion of residents accessing the service by age range compared to the proportion in the same age range in the population. Significant differences are indicated, and on the right is a heat map showing relative concentration of unmet need for a given condition in the local authority in scope. For the carbon emissions modelling, on a geographical level, we used LSOAs, or lower layer super output areas, and assumed all patients were living in the most populous location within their resident LSOA. We used the Open Route Service API to plot where the clinic locations in scope were on the map. We used another Open Route Service API to calculate the distance between each of these LSOA locations and each clinic. We then use published data on the proportion of people that travel by different means, for example, by car, bus, or train, as well as the carbon dioxide equivalent emissions for each of these travel means to estimate the carbon emissions created through patient travel to and from attended appointments for each clinic. We then produced the automated summary report, which was automatically created in MS Word, which identifies the top 5 features predictive of someone attending or not attending their appointment, the health equity audit showing the statistical differences between clinic attendees and the general population. It has the maps of unmet need for all reasons of attendance or condition modelled. It estimates the CO2 emissions from patient travel from their home to the attended appointments and back for the current service design, and also includes the appendices of all assumptions made, user choices, and a glossary of terms.
Okay, so I'm shortly just about to play a video of the tool running, and which will run through the code, and then subsequently the report that Sally's just described. It'll run through each stage, and each stage will appear in the top right to just keep you on track as to where it's at. There's a stopwatch that will be down here to give you an indication of the duration of each stage. And just to note, this is running at 4 times speed, just to fit it into the session we have this morning. So I'm just going to press play and then talk you through what happens. I should just say this is for a 3,000 record dummy data set, so the runtime does increase with increased data set size, mainly for the DNA machine learning models. So first off, there is the pre-processing stage. This is reading in the data set, cleaning the data set, and controlling for missing values. So where it's a text value missing, that's the word missing that's replaced, and where it's a numeric value, it's the median value that's used. Subsequently, the machine learning model takes place and has identified the optimum, how the health equity audit is completed using parameters from the user. The carbon emissions modelling is now taking place, so it's geocoding all of the clinics in scope currently, and now it's calculating the distance, so the 4,910 routes, possible combinations from LSOA, so those 10 in Derbyshire. The maps and now the report have been produced, and this is a report for a 40,000 record data set, which has been produced in under 11 minutes with all of the outputs from the model, from the various stages of the model incorporated, as you can see. So the maps in terms of unmet need or people not accessing where a prevalence rate hasn't been used, the DNA features, a glossary of terms, and appendices which include all of the methods that we've used, any assumptions that have been made in running the model, and any controlling taken place for missing data. Lastly, the charts from the HEA, all of which include significant findings indicated and acknowledgements at the end to all involved. So we were quite keen, we were quite fortunate actually. We had a public health registrar with our organisation during the work that was taking place for this project. So they'd undertaken a health equity audit manually, which gave us some comparative figures to sort of work through, well, what's the impact that one part of the tool could have. So with their input, we estimate that the HEA component is approximately 80 times faster using this tool than it would be to do this in sort of a more traditional way. So in real terms, that's about 15 minutes compared to 2 full days for one service. Now, as a provider of many services, we have approximately 35 service lines. So scaling that to an organisation, that's a sort of less than a day compared to 3 months of running these sorts of analyses to understand inequalities, or at a potential ICS level, so assuming 4 organisations of similar size, that's around 3 days compared to the best part of a year, factoring in annual leave. And I say hypothetical here because due to this sort of capacity barrier, this is one reason why these sorts of analyses don't often take place, and hopefully we can use this tool to get around that barrier and enable more insight more readily for inequalities present in services. So our next steps, we've collectively submitted a Healthier Futures Action Fund bid, which the outcome is TBC by the end of this week, hopefully. We intend to, hopefully, if that's awarded, use that to develop additional functionality. And that's sort of a couple of things there that we're thinking. One is, now that we've modelled the baseline emissions for the current service design, what we'd really like to get to next would be to look at, if we were to put a new clinic in a given location on the map, what might the relative impact be on both emissions and unmet needs that has been modelled for the service. So that could help with inform, actually, we have several different locations we might choose, which one might be the best one, taking into account the co-benefits or trade-offs between those two things. Fortunately for that functionality, we've already had a conversation with one of our other HSMEs on this programme, who has kindly shared their code, and we might be able to use that as a basis in an open source way for that next step. Lastly, we're looking at repurposing the code for other uses. So for example, the machine learning part, looking at the DNAs, we were thinking, actually, could we repurpose that quite readily for other binary outcomes? So for example, looking at the demographics or features that might be associated with people who do or don't take up a particular vaccine, or do not wait within the certain target time, for example. So we've had a few reflections collectively on our experience with HSMA, and I think, particularly because we're working across different geographies, different organisations, and all 3 of us are from different sectors. So it's sort of proved that not only can shared goals be achieved 100% remotely, but also beyond normal and traditional organisational boundaries. In terms of the course itself, the online format has been incredibly accessible. I don't think comprehensive content does it justice. I think the content's enormous, but it does allow you to pick areas of interest and clearly apply, as people are showing today, application to current challenges. Just want to acknowledge a number of people who've been instrumental in the work that we've shared today. So I won't go through them all, but particular thanks to everybody on the screen and everybody else who isn't, who helped with questions as well. Thank you ever so much for listening to our presentation. If you've got any questions, really happy to take them either in the chat or in the breakout, and I hope you enjoy all the other sessions.